welcome back to the wrap-up session on spatial data mining. In the sequence of last 7 videos or so, we talked about what spatial data mining is and what it is not. We talked about different pattern families. We looked at statistical foundations, also the input data, and then we went into depth of many pattern families. Okay. So, at the end of this course, after you're done with all your quizzes and exam, or maybe a year from now, what should you remember? What's the takeaway message? Because there is a lot of details, and if needed, you can always come back if you are working in the field to dig into the details. But here are a couple of takeaways that I would like you to have. Okay, geospatial data is different. It doesn't meet many assumptions that you have with classical data coming from internet. Okay, so you saw that even in the input part. Okay, there were things which were different. For example, relationships. Many spatial relationships like distance or inside, outside, they are implicit and they have to be computed. So even if you are using classical data mining and you want to select features from spatial data, don't just look into what's already there in the table, but think about what other relationships like distance or inside are relevant to your problem, and have a spatial software, either database or GIS compute it for you, and then you could feed it into a statistical package. Also, the types are different. You remember points, lines, polygon, raster. These are more complex than numbers and text, and you have seen that in previous chapter as well. Okay. The second, you should remember that the statistical foundations are different. In classical statistics, for simplifying their calculations, they often made assumptions like IID. Learning samples are drawn independently from each other. They are from identical distribution. These assumptions are probably not true for very many data sets. But certainly in geographic data sets, these assumptions are terrible, and we showed you examples of that. So again, when you are analyzing spatial data, don't just use traditional methods like linear regression or Pearson correlation coefficients. Look at spatial statistical ideas so that you take into account spatial autocorrelation. Okay? And then finally, pattern families. And we showed you that whether you are doing association or clusters, the patterns in space have unique meanings. And you should look at techniques which capture that meaning well. If you don't, then your manual work of post-processing will be a lot more. Okay? So hopefully you will remember that geographic data is special, and it requires specialized statistics, specialized pattern families. And as long as you remember that, I think we did the job. But if you are diving into more details, hopefully you will use software available in MATLAB and R and ArcGIS to look at these techniques in more details. Thank you so much.